Good afternoon.
Good afternoon.
All right, so I can see the girls in Winslow. Okay, Mogion, who I see Jordan and Hannah and Rachel.
Rachel's here. Denon, Brett, and Hannah. Hannah's finishing up her test right now.
Okay.
And then Denon and Rhett are
We're all
around.
here.
Yeah, everyone's here. They're just
Okay.
taking a second.
All right, that's cool. And how about St. John's? Are those guys coming?
They should be coming in. We just got done taking the test, and I got done early, so they probably just barely got done.
Okay. All right. Great. But you saw them in there?
Yeah, they were.
Okay. Super.
Mr. Strong?
Yes.
I wasn't able to get into my test until like 2:25, so I wasn't able to finish the test.
So what's the Okay, so what did it just end?
Yeah.
So what was the problem?
I don't know. It kept saying that something was wrong and the link wasn't working, and there were people working on it, it said, and it didn't allow me in until just a little bit ago.
Okay. So all right. So okay, so for sure you definitely need your second attempt, right?
Yeah, I didn't finish my first one. I was on the last two questions, and yeah.
Okay, so I'll see what I can do to figure that out, but just go ahead and take when do you want me to open up the second attempt for you?
Could I do tomorrow at 1:50?
1:50? Yeah.
I mean,
1:30.
1:30.
1:30.
Yeah.
Okay. All right. So Nathan, 1:30.
Did you get to do your second attempt?
Second attempt. Okay.
I wasn't able to finish my second attempt either.
Okay. So I'll open yours up to.
Same time?
Tomorrow at 1:30. Can you make it tomorrow at the
Tomorrow at 1:30. Okay. Yours too. Okay.
Yeah, and could I just do like 5 minutes after class because I only have a couple more?
Can you go?
I don't think
Yeah.
once if you're in the middle of it, that's your attempt. You can't.
Okay.
I mean, in his case where he got ripped off on the time, I might can do something about it, but otherwise you can't. I mean, I can reopen for a second attempt, but once you go into it a second time, that's your attempt, and I can't give you a third attempt without giving everybody a third attempt. And so that's why I say if you don't think you're going to be able to finish, just correcting if you just missed a few and you've got 10 minutes and you only need a few to correct, you'd probably be okay. But if you have a lot, then you're better off not even starting that second attempt, okay? Because you've got that is your attempt, and then when you're doing the second attempt, guys, make sure you start off with marking the ones you got right. The ones you got points for, make sure you got those points, because absolutely you don't want to get a lower grade on your second attempt. That's just tragic. Okay, so start with the ones you got right, and then spend all your time on your second attempt working the ones that you got wrong. Okay. Because if you run out of time, then you're like, well, I didn't get the last 10 problems. Well, then that means you're lowering your grade. And you absolutely don't want that. Okay? Be better off not to even take the second attempt. All right? So if you so just don't do it. Don't take it and let me reopen it for you another time if you feel like that you don't have enough time. Okay. But I'll so Joey, you started your second attempt. Yeah. Did you remark the ones you got right? So at least you're not going to get a lower grade.
No, I didn't get done doing that yet.
Okay. All right. Well, I'm going to have to think about that because do you see what I'm saying about the third attempt? Because it's not really fair for me to give you a third attempt and then not everybody else. Do you understand that? Okay. All right. Well, but if there were any kind of extenuating circumstances, let me know. And because I hate to have grades hurt because of the thing, but you gotta think about what you've got there in front of you. All right. Well, okay. So, all right. Anything else going on today? All right. Well, okay. All right. Let's see. Okay. All right. Well, so today we're going to continue on 3-5, and let's see, that's where we are, 3-5, and go from there. Let's see if um, hmm. Hmm. Well, I can't. Okay, I'm trying to figure out. I'm. Well, just so you know, we're going to go on to 3-5, but kind of what I'm struggling here is we're a little bit jammed up for our time, and I kind of think that we might need to have another Moodle day. So let me think about this while I'm teaching here. I can basically what it is because we have we're trying to do all this testing during the week, and I kind of feel like that if I were to just throw another day and say, okay, you have another set of quizzes or another test to do outside of class, I kind of feel like that's being unreasonable. All right, at least I feel that way. So I hate missing any class time or whatever, any teaching time, but I've got to somehow balance this whole quiz and test thing. So, well, let me just throw this out there and let me have you guys shoot it down if this is a bad idea. Because what I'm worried about is, that if we have 3 tests or 3 quizzes next week, and then 3 the next week, and then we have the midterm. And then we have the chapter 3 test, and then the midterm. That puts our midterm out into like mid-November, and that's not cool. So we're gonna need to push it up a little bit, and I think the way to do that is for me to have like one day of class and just say, okay, I'm gonna give up a day of class so that you can take another couple of quizzes or something like that. I've never actually had to deal with all of this before, and so I would love to have some feedback here, as how you guys, what you think that we could do to solve this. Any ideas? Or anybody, like, what if I said tomorrow, I just want you to do quizzes, we're on quiz 3.3 and 3.4
Instead of class, or
instead of class.
I guess that'd be okay.
Can anybody see a problem with that?
For those of us that haven't finished the 2 chapter test, I can see a conflict with that, because now we have to study for not only that test in the entire 2 section, but the 3.3 and the 3.5 section too, and that's a lot of studying added to any other homework.
Right, and I totally agree with that 100%. But what's going to happen here is we're going to get jammed up for the midterm. And so then you're going to have, instead of a test, chapter 2 test, and 2 quizzes, you're going to get jammed up on a test and a chapter 3 test and a midterm. Or, at the end of the semester, the final. And so I'm seeing that right now that we're getting jammed up. And so I got to figure out something. But I agree with you 100%.
So why not do the tests on another day? So still do them this way and have a Moodle day, but not tomorrow, because some of us are already taking a test tomorrow.
Okay. Oh, I see what you're saying. So having a Moodle day, you're not saying that that's necessarily a bad idea, just maybe not tomorrow. Okay. All right. No, I get that. Because you guys are, some of you are taking your second attempt in the morning. I guess that there's 4 or 5 of you now. So
I think it's fine whichever way we do it, but would doing the quizzes like that put us behind on notes, or?
Well, and see, I got to balance that too. So you're absolutely right, and that's something that I've got to think about. Usually, and I'll just throw this out there too, is that I want to cover chapter 6 as much as I can, but I think I already told Jordan that, like, when we get to chapter 6, because this chapter 3 is by far the biggest. It's just huge. And then 4 and 5 go pretty quickly, and so does 6. But the last chapter, depending on how far we do it, I kind of make that extra credit. What I do is, if you take the chapter 6 test, I kind of let it. I'll either drop it or drop your lowest test if the chapter 6 test beats your lowest test. So if you did poorly on a test, you can, drop your lowest test. So because, usually, anyway, that's kind of what I'm thinking there at the end. But that's really a conversation.
I'm just trying to understand what you're saying. Are you saying, like, tomorrow we won't have class and we'll just do the quizzes?
Well, it sounds like that if students are feeling jammed up tomorrow, we're not going to do that. We'll go ahead and have class, and but that's what I was thinking about is one day. So maybe not tomorrow, but one day I was thinking, let's not have class and just have another Moodle catch-up day and do some quizzes and stuff.
Are we doing quizzes tomorrow though? Still, because I will not be here.
Yeah.
Yeah.
Tuesdays and Thursdays.
Could I do, if we're doing the quiz tomorrow, could I do it Friday?
No, we're saying we're not doing that. We're not going to do
Oh.
it tomorrow. I just threw that I just threw that out there, and but I understand the idea of if you're taking your second attempt on the test too, that might be tough to do with a couple of quizzes. So I don't want to jam anybody up. So we'll just have regular class tomorrow, okay? So I'm not gonna. The only thing I'm gonna do tomorrow, as far as the Moodle, is I've got you guys in St. John's looking at a second attempt, and so I'll look through that. I'm gonna look at the last couple of questions on Nathan's eventually, probably not by tomorrow. And then I've got Joran and Hannah W. taking their second attempt in the morning. So that's all we're doing as far as quizzes. Those.
I'm gonna email you the rest of these guys. Just finished taking their other tests, so I'm gonna email you a time.
So there might be some more second
They-
attempts tomorrow?
They only got their first attempt done, so
Okay. All
I
right.
will send that to you.
Well, we'll deal with that. I'm like I said, I just don't I don't want to jam anybody up one way or the other. So we'll just kind of go with the flow. And you guys, I appreciate the feedback, and because I don't want to I don't want to overload anybody here. But all right, well let's just go on. So we're gonna have a regular class today, 3-5. And then we're going to do our class tomorrow. Okay? All right, so we are on, we're in the middle of the derivatives of trigonometric functions. All right, so we were talking about what are some harmonic functions. And so one of the ones that I said at the beginning was a spring. And so this is kind of the idea of a spring. So there's kind of two actions that you can perform on the spring. You can compress it or you can stretch it. But either way, when you let it go, it's actually going to go through, it's going to go up and then down and kind of bob up and down. So anything that kind of goes like that, that's harmonic motion and can be described with the trig function. So let's say that this blue graph represents the harmonic motion here of a spring or something like that. So that's our S. So S equals 5 cosine t. All right, then what would be the velocity function? What would be the velocity of this function, of this spring? So if this is the position, what's the velocity?
5 minus sine t.
Well, it would be 5 times minus sine t, so you put the negative in front so that you don't think it's 5 minus. It's 5 times negative sine t. So negative 5 sine t. All right, and then, so then what would the acceleration be?
Five.
Just 5?
2 pi? I don't know. I'm just shooting.
No. So once you have the velocity, to get the acceleration, you take the derivative. So to take the derivative of negative 5 sine t, you say the derivative of negative 5 is just, you bring down the negative 5, the constant in front of a function. And then the derivative of sine t is cosine t. So the acceleration would be negative 5 cosine t. Okay? And then, did I tell you what the derivative of the acceleration was? Did we talk about that? The jerk. It's called the jerk. So it goes position, velocity, acceleration, and jerk. Okay? So the jerk is the derivative of the acceleration. So what would be the jerk function?
5 sine t.
5 sine t. Okay, good. And now what would be the rate of change of the jerk function? Or what's the derivative of j?
5 cosine t.
Right, so we'd actually go back to where we started. Okay? So, anyway. Okay, good. All right. So it says a body hanging from a bungee cord is stretched to 20 meters beyond its rest position. Okay, now, I don't know if you guys, have any of you ever done any bungee jumping? So this used to be a big thing in like the 80s. And there were people that actually died from bungee jumping. And what they would do is they would get the rope or whatever, the bungee cord, and they would measure it, and they'd be like, oh, this is 50 feet, and the bridge they're jumping off would be like 55 feet from the bottom. And so then they would jump, and then they would die. Why would they die?
Because they measured the length of the rope, not how long it stretches.
Right. And it's sad to say that, that it was death by math skills or something. They weren't getting it. But anyway, the bungee cord stretches. That's the whole idea. So it stretches up to 20 meters beyond its rest position and is released at time t equals 0 to bob up and down. Its position at any time t is s equals 20 cosine t meters. What are the velocity and acceleration after 2 seconds? So now I'm asking you to find the velocity and acceleration functions and then plug in 2. Okay? All right, so Damon, what do you have for the velocity at 2 seconds?
The dream.
Say it again, please.
Hang on, I'm still thinking.
Oh.
So it doesn't matter.
No, it does matter, Nathan. We're right. You're wrong.
3.
So what's your answer?
Negative 18.9.
I got negative 18.186. I'm not sure where your 9 comes from, but anyway. So the derivative is negative 20 sine t. You plug in 2. Make sure when you're putting it in your calculator, you're in radian mode. Okay, so when you're doing all the trig functions, you need to be in radian mode.
So does it matter what decimal point you round to?
Yeah, I want you to carry it out to 3 decimal places.
Okay.
Okay? That's kind of the standard for calculus. Okay? All right. Then the acceleration at 2 seconds. All right, Joran.
Um, 8.323 meters per second.
All right, that's it. It's actually, the units are per second squared. Okay. All right. Anything else? Okay. Whoop. Okay, so the jerk is the third derivative of the position, and the second derivative of the velocity, and the first derivative of the acceleration. So the order, it goes position, take the derivative velocity, take the derivative acceleration, take the derivative to get the jerk. All right, so it says find the jerk if S is 10 sine t. Well, so to get the jerk, you're going to have to take all those derivatives. So first derivative would be 10 cosine t. Then the acceleration would be negative 10 sine t. Then the jerk would be negative 10 cosine t. So you'd have to take the third derivative. All right? All right, so now go ahead and do practice 4, please. All right, so Skylar, when you've got it.
$18.186.
All right, very good. And so then the units for jerk in this problem would be meters per second cubed, okay? Because each time it's like you're dividing by a velocity, taking the derivative with respect to time. And so the units for velocity would be meters per second, for acceleration, meters per second squared, and so for jerk, it's meters per second cubed. Okay.
What exactly is jerk measuring?
Kind of like whiplash. Okay? Like if you're driving and you hit the accelerator, all right? And so you're changing your acceleration. And then let's say you run into a tree and then your acceleration is changing radically. Okay? Then that kind of like that whiplash, that jerk, that's what it's measuring. Okay?
So like with the bungee cord or whatever, it would be the force that launches it back into the air once it stretches all the way?
Well, in a sense that, okay, so here let's see. Let's see, for the bungee cord, what would be the jerk? I think in that case, Yeah, I guess it would be that pole, because you have gravity just pulling you down, and then when the thing jerks you back up, that would be the measure of like what would be that force that is pulling you back up. Okay.
Cool.
So there's different kinds of springs or bungee cords or whatever, and each of them have what they call a spring constant. And so you could actually calculate that and figure out what that force is. Okay. So anyway. All right. Well, thanks for that question. Let's see. And then this is like a calculus insult. You ever want to tell somebody an insult that they can't understand? Anyway. Okay, so next, the derivatives of the other trig functions. Okay? So the derivative of the tangent is the secant squared. The derivative of the secant of secant x is secant x tangent x. The derivative of the cotangent of x is negative cosecant squared x. And the derivative of cosecant x is negative cosecant x cotangent x. And so these other two are ones we already did. The derivative of the sine of x is cosine x. The derivative of cosine x is negative sine x. So that's your 6 trig functions and their derivatives. All right. Anybody need more time on that? So these I would recommend that you memorize, those 6 derivatives. Okay? It will help you greatly down the road. Okay? All right. So what I'm going to do is prove to you that the derivative of tangent, the tangent of x is secant squared. Okay, so I'm gonna prove this to you. So this is the type of proof that we do in calculus. So if you're gonna be a math major or math educator or something, you might want to write this down. Otherwise, you can just watch and kind of see the flow of it. Okay, so you say, well, tangent is sine over cosine. That's a quotient identity. And so now if we wanted to take the derivative of that, we could use the quotient rule. To start with the denominator times the derivative of the numerator, which is sine x, minus the numerator, sine x, times the derivative of the denominator, which is negative sine x, all over the denominator squared. Well, now if we simplify, we get cosine times cosine is cosine squared. Negative sine times negative sine is plus sine squared x. Well, cosine squared plus sine squared, that's equal to 1, Pythagorean identity. And then 1 over the cosine is secant, so 1 over cosine squared is secant squared. All right? So that's actually how we would prove the derivative. Okay? So I did this one using the quotient rule. All right, so see if you can do practice 5. So prove that the derivative of secant x is secant x tangent x. Yeah, see if you can figure out what you might do in that one. All right, so if you're not sure where to start, I'll give you a hint. Rewrite secant x as 1 divided by cosine x. All right, so Joey, what do we do next?
Okay, do you take the derivative of the, so you do the, can't remember what it's called, but the u prime times v prime plus u times v prime, right? So first you
Okay, no, well, we're going to use the quotient rule. So it's v u prime minus u prime v over v squared.
okay.
See, we don't have a product here. We're not going to use the product rule. We have a quotient. We're dividing.
Okay, so we're starting with the secant x and then going to secant x tan x.
Yes.
Okay, I did it the other way around.
Yeah, that's the answer should be secant x tangent x.
Okay.
All right.
Oh, I got it. Haha.
So just pretend that this is the problem now. How would you take the derivative of 1 divided by cosine of x? So Joey, if you apply the quotient rule to this, what do you get?
So the derivative of v or u would just be 0, right?
Yes. So
So-
you would start with the denominator. So cosine x times 0. So the derivative of the numerator is 0. So that term's going to go away. Then minus the numerator times the derivative of the denominator, which is negative sine x, all over the denominator squared. So well, then what does that simplify to?
Just sine x over cosine x.
Sine x over cosine squared x.
Yeah, squared, sorry.
All right, and then what can we do with that? Actually, anybody, help me out here.
Well, so sine over cosine is tangent.
Yes.
You pull that out.
But
Keep talking.
You pull that out, and then you have 1 over cosine x, which is actually secant x.
Secant x. So you have sine over cosine, and then you have 1 over cosine, because you have the 1 cosine left, and so that's tangent x times secant x, or secant x tangent x, however you want to write it. So that's it. That's it. Good job. Okay. All right. Any questions on that? All right. So, like we were talking about before, is we can do higher derivatives. So to take the second or third derivative of a trig function, just use the same rules. Okay. There's nothing special. Just like when we went to the jerk, by taking the third derivative, all the rules apply. You just take the derivative again. All right, so go ahead and try, do practice 6 and find the second derivative. So there's the first derivative. How do I get the second derivative? What rule am I going to need here?
Product rule.
Product rule. Okay. All right. So Rhett, when you've got it. All right, Red, you got it, or need some help?
Yeah, I'm confused.
Okay, so so to use the product rule on this, so think of this is your u, negative cosecant x is your u, cotangent is your v. So the derivative, the second derivative, you take the first, negative cosecant x, times the derivative of the second one, the v. So the derivative of cotangent is negative cosecant squared x, plus cotangent x times the derivative of negative cosecant x, which is cosecant x cotangent x. It's already had a negative, so when we take the derivative of it, the negatives cancel. So then simplifying here, negative cosecant x times negative cosecant squared x is positive cosecant cubed x. And then you could distribute the cotangent. Well, actually, it's not distributing, just multiplying together. Cotangent squared x cosecant x. Okay.
Okay, yeah, I got that. I just couldn't simplify it. So
No, that's fine. You can leave it right there. Because, yeah, you could, like, factor out a cosecant, but there's nothing you can cancel. There's nothing to combine, so you could just leave it like that. Okay? All right, well, the last thing here is talking about limits. It says we can calculate limits of algebraic combinations and composites of trigonometric functions by plugging in. So even though they look complicated, just plug in. So on practice 7, just plug in 0 for x and try to work it out. Okay? So that's all I'm saying. Just try plugging it in. Even though it looks more complicated than we know how to do, it's really not that bad. So as x approaches 0, so try plugging in. If you don't get 0 over 0, then you're golden. All right, so David, when you've got an answer.
-1.
-1, let's see. Oh, okay, I got 0 because, see, the cosine of 0 is 1. So you get 1 minus 1. So the square root of 0 is 0. And then the denominator you get -1. So that's still equal to 0. So that's good. Get an answer of 0. Okay, any questions? All right, so we'll pick it up from, we'll be on the 3-6 tomorrow, okay? All right, so I'll look for an email from you, Miss Townsend, and we'll see you guys tomorrow then. Okay, good luck.